Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Polynomials. Here are the questions and solutions from exercise 3.2 and this is part 1 video. In this video, we will learn the solutions of question number 1 and question number 2 of the exercise 3.2. The chapter Polynomials and exercise 3.2. Look at question number 1. The graphs of polynomials p of x are given below, and in each case find the number of zeros. I shall repeat. The graphs of polynomials of p of x are given below. In each case find the number of zeros. Dear students, here is the first graph. The horizontal line of reference and vertical line of reference. Horizontal line of reference is called x-axis and vertical line of reference is called y-axis. Okay. Now look at this graph. This red line represents the graph. Now this graph is a straight line. Is it cutting x-axis? Is it intersecting x-axis? You verify. At how many points this graph may intersect x-axis? Here this line, this straight line does not touch x-axis. Since it does not intersect x-axis, there is no zero for this polynomial. Therefore, the number of zeros for this graph, number of zeros is equal to 0. The number of zeros of a graph is nothing but the number of points at which the graph intersects x-axis. Here, in this case, in the first case, the given graph is intersecting y-axis, but it is not touching x-axis. In other words, it is parallel to x-axis. Now look at second bit now. Again x-axis and y-axis, these two are intersecting at origin. Now this is the graph. This graph intersecting x-axis at how many points? This graph, this curve intersecting x-axis at one point. Then the number of zeros of this polynomial is equal to 1. Now look at the third graph. In this third graph, again both an x and y axis, and this is the curve. Now this curve is intersecting x axis at how many points? You may please count. And this is the first point of intersection, this is the second point of intersection, and this is the third point of intersection. This curve is intersecting x-axis at 3 points. Then number of zeros of this polynomial is equal to 3. Please keep in mind, in whatever the graph is given, in order to find out the number of zeros of the given polynomial, we have to verify at how many points the given graph is intersecting x-axis. The number of intersecting points is equal to number of zeros. Why it is so? Because we know that the zero of a polynomial is nothing but the value of the variable for which the total polynomial is 0. In order to get the 0, the value of the variable x, you have to find out the value of the variable for the total polynomial 0. Okay, look at question number 4. In this, again I have given x and y axis, and this is the given curve. And this curve is intersecting x-axis at 2 points. This is first point and this is the second point. Since it is intersecting at 2 points, okay, since it is intersecting at 2 points, the number of zeros of this graph is equal to 2. And the next bit, fifth bit now. Now the given curve is like this, and this given curve is intersecting x-axis at 1, 2, 3 and 4 points. Since it is intersecting x-axis at 4 points, the number of zeros of this curve or of this polynomial is equal to 4. I shall try to explain why the number of zeros is equal to the number of points at which the curve intersects x-axis. The reason is, at this point of intersection on x-axis, For any point on x-axis, can you say what is the value of y-coordinate? Yes. For any point on x-axis, y-coordinate is always 0. Means y is equal to 0 is the equation of x-axis. That is, for any point on x-axis, y-coordinate is 0. If I given a polynomial x plus 2 and you are asked to find the 0, then what will you do? You will equate x plus 2 to 0 and you may find x value. Similarly, here also we have given a polynomial. If you draw the graph of a polynomial, you will get a curve or you will get a straight line. Now, if the curve is intersecting x-axis, means that point on x-axis, y-coordinate is 0. Polynomial of the variable is 0. If the total polynomial value is 0, then you have to find x value. That x value itself is the 0. Therefore, you have to find out the number of zeros. You have to find at how many points that curve may intersect x-axis. In this case, this curve is intersecting x-axis at 4 points. Therefore, the number of zeros of this curve is 4. And next, the sixth bit now. This is the curve. Look at this curve. This curve is intersecting x-axis at this first point. This is the first point of intersection, and this is not the point of intersection, it is just touching x-axis. Therefore, there is another only one point is here. First point, second point, again it is touching x-axis at another point. Therefore, there are 3 points of intersection. Exactly, there is only one point of intersection and the other 2 the points of contact. Anyhow, there are 3 common points for x-axis and this curve. How many common points are there? 1, 2, 3 common points. Therefore, the number of zeros of this curve is equal to 3. Number of zeros is equal to 3. Now, what can you conclude from this? You should understand that the number of zeros of any curve is equal to the number of points at which the curve intersect x-axis. The number of zeros of a curve is equal to the number of points at which the curve intersect x-axis. Okay, let us see question number 2 now. Find the zeros of the following polynomials. P of x is equal to 3x. Second bit, P of x is equal to x square plus 5x plus 6. And third bit, P of x is equal to x plus 2 into x plus 3. And fourth bit, P of x is equal to x power 4 minus 16. I shall repeat. Find the zeros of the following polynomials. First bit, P of x is equal to 3x. Second bit, P of x is equal to x square plus 5x plus 6. Third bit, P of x is equal to x plus 2 into x plus 3. And fourth bit, P of x is equal to x power 4 minus 16. Here is the solution. We have to find the zeros. Then let us write what is meant by 0. The value of the variable for which the value of the polynomial is 0 is called the 0 of the polynomial. In order to get the 0 of any polynomial, either in the first case, second case, third case or fourth case, 0 of the polynomial is nothing but the value of the variable for which the total polynomial becomes 0. Means, for example, if you substitute x is equal to minus 2 here, then minus 2 plus 2 will be 0, 0 into whole, this will be 0. Therefore, if you substitute x is equal to minus 2, then the value of the polynomial becomes 0. Therefore, minus 2 is one of the zeros of this polynomial. Like that, the 0 of any polynomial is nothing but the value of the variable for which the total polynomial becomes 0. That value of the variable is called 0 of the polynomial. Okay, let us solve the first bit now. P of x is equal to 3x. 3x is the first polynomial. We have to find the 0 of this polynomial. Now, in order to get the 0 of this polynomial, the 0 of the polynomial means the value of x for which the total polynomial becomes 0. That is, equate 3x to 0 and find x value. If 3x is equal to 0, then x is equal to 0 divided by 3. Why? because this 3 is multiplying x and LHS. If we take it to RHS, it should divide 0. Therefore, x is equal to 0 divided by 3. What is 0 divided by 3? Which is 0. Therefore, x is equal to 0. So, 0 of the polynomial p of x is equal to 3x is 0. And let us solve second bit now. Second bit polynomial is x square plus 5x plus 6. Now let us find the factors for this quadratic polynomial. X square plus 5x plus 6. Let us divide this into two factors. Here 6 is there. You can write 6 as the product of two numbers as 1 into 6 and 2 into 3. But since the coefficient of x is 5, you should take 2 and 3 whose sum is 5. Therefore, you can write x square plus 5x plus 6 as x square plus 2x plus 3x plus 6. You learned how to find the factors of a quadratic polynomial in 9th class. You can use that knowledge now. Now take x common from the first two terms. If you take x common from x square, you have another x. Plus if you take x common from 2x, you have 2. Therefore x into x plus 2. And from these two terms, take 3 common now. X plus 3 in 6 2 times. Therefore this is 3 into x plus 2. Now take x plus 2 common. X plus 2 into x plus 3. Therefore x square plus 5x plus 6 can be factorized as x plus 2 into x plus 3. Now we have to find the values of zeros. In order to find the zero of this polynomial, x square plus 5x plus 6, it should be equal to 0. The total polynomial should be 0 for some value of x. That some value of x is to be found now. But we know that x square plus 5x plus 6 can be written as the product of x plus 2 and x plus 3. Therefore, x plus 2 into x plus 3 is equal to 0. Since the product of two numbers is 0, either the first number may be 0 or the second may be 0. If the first is equal to 0, that is if x plus 2 is equal to 0, then x is equal to plus 2 other side minus 2. Or if the second value is 0, that is if x plus 3 is 0, then x is equal to minus 3. That is there are two x values. One is minus 2 and the second is minus 3. If you substitute x is equal to minus 2 in the given quadratic polynomial, you will get the total polynomial 0. And again if you substitute x is equal to minus 3 in the given polynomial, it will become 0. You can try. Therefore, there are two x values. There are two values for variable x for which the total polynomial becomes 0. Then you can say that minus 2 and minus 3 are zeros of the given polynomial. So, zeros of the given polynomial x square plus 5x plus 6 are minus 2 and minus 3. Now, if you observe the third bit is given that p of x is equal to x plus 2 into x plus 3. Straight away we have given this x plus 2 into x plus 3. Previously, in this case, I have given a quadratic polynomial, then we divided or resolved into factors. But whereas in this case, you need not go for factors. Factors itself are given. If the factors are given, then straight away equate each factor to 0 and get values of x, so that you will get the two values like this only. Now, we will solve fourth bit now. P of x is equal to x power 4 minus 16. We have to find the zeros for this quadratic polynomial. X power 4 minus 16. That is x square. X power 4 can be written as x square whole square. X square whole square minus 16 means 4 whole square. This is in the form of a square minus b square. What is the formula to find a square minus b square? A square minus b square is equal to a plus b into a minus b. If we assume that x square is a and 4 is b, then this is in the form of a square minus b square, which is a plus b into a minus b. A plus b means x square plus 4 into a minus b, x square minus 4. You cannot divide x square plus 4 into factors. Therefore, write x square plus 4 as it is. But x square minus 4 can be written as 2 square again. Now, this x square minus 2 square is again the same formula model, that is a square minus b square. First of all, x square plus 4 into, now it is a square minus b square, therefore a plus b into a minus b, that is x plus 2 into x minus 2. Now, these are the factors of x power 4 minus 16. We resolve x power 4 minus 16 into factors. Now let us equate it to 0. To find the 0 of the polynomial p of x, let px is equal to x power 4 minus 16 and is equal to 0. Then what are the factors of x power 4 minus 16? X square plus 4, x plus 2, x minus 2 equal to 0. Since the product of three values is 0, either at least any one of them should be 0. So either x square plus 4 is equal to 0, then x square is equal to plus 4 other side minus 4, and x is equal to square root of minus 4. Can you find the square root value of a negative number? We cannot find the square root value of a negative number, otherwise it is an imaginary number. Square root of minus 1 may be represented with I. Square root of 4 is 2. Therefore, you can write it as 2i. If x square is equal to minus 4, then x is equal to 2i. I means root minus 1. And the second value, if x plus 2 is equal to 0, then x is equal to plus 2 other side minus 2. Or if x minus 2 is equal to 0, then x is equal to plus 2. So, the zeros of the given polynomial p of x is equal to x square minus 16 are 2i plus 2 and minus 2. Otherwise, you can write this plus 2 as plus or minus 2i. At once, you can write plus 2i, and the second case, you can write minus 2i also. So that there may be 4 zeros. Thank you, one and all.